Okay, yeah, we're recording now. For today's class, I'm going to answer a couple questions and then talk about a couple of topics that we've mentioned before, primarily based on the ISO 95 template. That's going to be our focus for today. I'm going to talk more about that here in just a second. And after I answer the questions that I got, I'll open it up for general questions also. So as a couple of people requested, I also scheduled a Thursday Q&A like we did last week. So be sure and send me the questions if you have them, and I will set something up in advance or just answer whatever questions you happen to have at that time. So let me share my screen here. Share screen. Okay, can you guys see my screen now?
Yes.
Okay, so this is just our schedule, and here we are today. We're going to do, as I said, the ISO 95 templates and a couple miscellaneous topics. I have the Zoom Q&A session. Next week, we have a guest lecture. And so I have this attendance is required for you on-campus students. It'll be by Zoom, so it should be pretty simple. Garrett Zaman is going to talk about where simulation-based scheduling and Simio RPS fits in Industry 4.0 and some of the live connections to data systems and so on. So hopefully that his discussion is really going to be a non-technical discussion, and hopefully will provide some context for the stuff that we've been doing. I also went ahead and scheduled for the next couple of Thursdays Q&A. We can do Q&A if you have that, though, if you have questions. I'm going to assign case study 5 after Garrett speaks. So I will then, we can discuss that on the following Thursday. And then, as I mentioned in class last time, on the week before the exam too, I'm going to do a detailed review of the material. So it'll be a bit more than a simple listing of the material. I'll talk in a little bit more detail. And then again, we can have one final Q&A session that Thursday, if you guys find that valuable. So let's see here. The questions I got today, there were really, well, one question and one note from me that are both related. The question was, can I elaborate on utilization of each station? So that was one of the requests for case study 4. One of the performance metrics was utilization of each station. And as I was trying to put together the answer for that question, I stumbled upon this issue with interactive dashboards. So let me show that when I'm talking about, and then I'll talk at the same time about utilization of each station. So here's my model. One of the models that I did for the Avi Electronics. I think this was case study 3 with the dashboards added. For the dashboard video is the particular model. It doesn't really matter which one we have. I used one of the dashboards, but the dashboard that I'm using here was one that was pre-done that we have done since the beginning of the semester. So the first thing I'm going to do is go to run, and I'm just going to reset everything so that if I go look at my results, I have no results. Well, let me reset that one more time. Let's see. So yeah, I have no results. If I go, why am I showing results here? Oh, if I have planning, I show no results. I go to results. I want to reset this. Stop the model. Yeah, don't know why I'm seeing results there on the reset, but nevertheless, we will proceed. So I was trying to answer this question or figure out the best way to answer this question of utilization. And so to do that, what I did was I just ran in fast forward mode. And then I looked at the results, and what I was particularly interested in, I just kind of focused in on this finish 1 station, primarily because it was at the top of my results. And I said, you know, we have the traditional metrics that we use, that you've used with Simio since probably the beginning of when you started learning Simio, this notion of scheduled utilization. And in Simio, scheduled utilization takes into consideration the on-shift time and the off-shift time and so on, and provides you this metric of, you know, kind of expected utilization. It also gives you resource states. And so for this resource, it's one of the finished stations. So it has sequence dependent setups. So we have the processing time here, the setup time, percent and total time, and then the time starved. And so it's this time processing that was primary of interest that is used for that scheduled utilization. So then I jumped over to the dashboard reports that we did. And I was looking at this one in particular. And so here is the that dispatch list, and here's finish one, and there are those three same metrics there, but the numbers are slightly different. You can see here that this is processing 60.87, starve 10.74, setup 28.39, and go back and compare that, to our pivot grid, and those numbers are just slightly off. And so this really confused me at first. And so finally, I just kind of stumbled on the fact that if you stop the model rather than just going to the endpoint, the numbers all synchronize. And so now you'll see those numbers match exactly the numbers from the pivot grid. So the reason that happens, as I mentioned in the slide, is because the way Simio does logging, that last log record doesn't get recorded until you actually stop the run. Because as you know, if we can run to the end of a current run, and if I want to run longer, I can go back in, well, if I'm running for a fixed time anyway, I can go back in and extend the time and run further. So the way they deal with that is by not doing this final log entry until the model stops. And so that was what I wanted to point out, so that if you were seeing something similar, you would not wonder what was going on. And where you would also see it is if you were comparing the planning view. So if I did, create a plan using and look at the and look at that same thing. Oops, that's not where I wanted to go. I wanted to go to results here, dashboard results, and then that same view here. And so if you were comparing this dashboard to this dashboard without stopping the run, those would appear different. Okay, so again, if I do this one without stopping the run, it's 60.87. And then if I compare that to the same dashboard in planning view, it's 59.55. And that's because this one hasn't written that last record. And as soon as you stop the model, it does that. Okay, does that make sense? Any questions about that?
It's not a question, but I did notice that happens too when you look at the make span.
When you look at the make span on the, you mean on the very bottom?
Yeah.
So when I'm looking in the facility view down here.
I noticed when I was doing that before, I would encounter like different numbers, but then I would stop the model and then I would say, okay, they're the same. Like when I compare these to the dashboard.
Yeah, you would definitely see it in the dashboard. So if I go over to the results and then look at that, the make span dashboard that I did, this one would potentially change. It really depends on what that last record is. Yeah. So that's good information to have. And like I said, I didn't know that until I was working on this particular question.
Yeah.
So back to the original question of, well, what do we mean by utilization? Well, there's the simple version of, well, just this, the scheduled utilization is one measure. It gets a little bit more interesting when you incorporate changeovers and when you think kind of theoretically about what do you consider utilization. So if we go back to our pivot grid, for example, we can look at this time processing. And if you say, well, my percent processing is 59.5, that would lead you to believe that the machine's idle for 41% of the time, when in fact it's not, right? Because it's only idle for 12% of the time because it's going through this setup. So there's a little, there's no specific definition of utilization, but what I was looking for in this one is just this scheduled utilization, or a measure similar to scheduled utilization that you could get in a dashboard. Okay. And so those are the two questions I have for today. Does anybody have any additional questions for me? Okay, let me stop this, go back here. That's where I want to go. And now what I want to talk about is the ISO 95 templates, and start out with what an ISO 95 template is. And the ISO, when you hear the term ISO 95, this is an international standards organization. And the ISO 95 standards, as you can see here, have to do or set up by and managed by this International Society for Automation. And the basic idea is that you want to develop a set of consistent terminology so that we can provide consistent information models and operational models so that different software can work together. Okay, and so as you know, or as we've talked about several times kind of at a high level, and that Garrett is going to talk a lot more about next Tuesday, is that the focus of using Simio RPS as a scheduling tool is this integration with enterprise level systems above it and execution systems below it. And so it's really important to have this consistent terminology and consistent information model so that you can ease the transfer of information between those systems. And so what Simio provides are two different templates. So you have two different ISO 95 templates, which I'm going to show here in just a second, I'm going to talk about here in just a second. The first one is the order-based routing, and the second one is process-based routing. And we can get to those. Let me see here. If I just go to File and then do New from Template, you can see they're the two templates that I mentioned, and there's the template that we did earlier in the semester. So if I just click on this one for the product-based routing, as we've talked about before, what the template provides is a set of data tables, the corresponding relationships between those data tables, a set of custom objects, and in this case, a default entity object instance. So we're going to see those all here in just a second. And there's an example model that we're also going to use, and this is scheduling discrete part production. So if I go back into my Simio model, and the scheduling discrete part production is based on this ISO 95 product-based template. So if I go to the support ribbon and go to examples, you can see here's the list of Simio examples, and we're looking for scheduling discrete part production right here. So let me just open that up. And if you look at this, you can see that it has the exact same schema, the table structure and so on. It just provides some data so that you actually have a model, whereas with the template, you just have the data structures. Something else that this provides is you have this nice PDF document that describes the organization of the model, how it works, how the table structures are set up and so on, but also it provides a set of CSV files. So you have if you look in the examples directory from your Simio install, you can find those CSV files. And then the instructions in this PDF walk you through starting from a template, just a new model from template, and then reading in all of those CSV files, and then ending up with the same model that you see right here. So that would be something worth looking at some point. We're not going to do it in class, but that's something that you should have a look at. I think I mentioned before that my initial plan was to migrate towards the ISO 95 template, and then for this final case study to switch from our basic template that we've been working on for now 2 case studies to the ISO 95 template. And as we get into some of the details of the ISO 95 template, you're going to see that we're pretty close to there. There are a couple of minor, or well, not necessarily minor, but there are a couple of differences I'm going to talk about today. But it wouldn't take too far to go from where we are to this template. And I think you're going to see some of the similarities. One quick note here. Let me see if I can find it here. Depending on what version of Simio you're running, the directory here is wrong. So the directory where the CSV files are stored, if you are running the 32-bit version of Simio, this will be correct. If you're running the 64-bit version of Simio, then it's in the Simio installation path, which is the program files, Simio LLC, Simio examples is where those files are. But other than that, everything else is the same. Okay. So have a look at that ISO 95 template. As I said, we're not going to go through it in detail. We're not going to do any more with it than I'm going to talk about here today. Try to give an overview of how it works and what the differences are between what we have now and the template. Because as I said, there are quite a few similarities. The basic structure is the same. A couple of key things that we haven't done. So the first question is, we have 2 different templates. We have the product-based routing, we have the order-based routing. And the fundamental difference between these two is how the routings are mapped. And so in the product-based template, the routings are mapped to materials. That's exactly like what we do. So we have an order, and the order is for a material, and the material is mapped to the routings. Okay. And so if you look at that, here is the table structure. You can see that there are a few other tables that we don't have, but you can see we have the materials table, the orders table, the routing table, the bill of materials table, resources table, and then these other tables that we're going to talk about here in just a little bit. But this key mapping here is material name to routing. And so that material name here is a foreign key and a primary key here. And so when you define a manufacturing, when you define an order, what they call manufacturing orders in the template, you're specifying materials, and think of materials in this context as a product. With the object, with the order-based routing, it's a little bit different. In the order-based routing, the routing key is tied directly to the order. So you can think of this as having unique orders. And so the order itself defines that routing key, and with the routing key is defined the bill of materials and all of that kind of stuff. And so really everything else is really, really similar between these two. It's a matter of whether the orders come from, a common set of products where an order can, an order is specified by a product, or whether the orders are unique, and for any given order, you specify the routing and bill of materials and so on. Okay, makes sense? Any questions so far? Anything at all? Okay.
All right, I have a question.
Okay, ask away.
So for the stuff, for the things you had, like blue paint and all of those, all of the logic where we did for the changeover, we have an extra column. Does that break the standard?
Can you talk just a little bit louder? You've got an echo in your microphone.
Okay, let's fix it. Is it better?
A little bit. Just talk a little louder and maybe I can get it.
Okay.
Yeah, that should work now better.
Yeah.
All of the things that we did on the case study 3, where we changed, we added extra elements to the tables. Do we have to follow the standard when we add additional things to the tables?
When you say, do you have to follow the standard? I'm not sure what you're asking me. So like, are you saying you want to do something different than how I did it in the video?
No, I mean, not for the case study. Here, these templates follow, as I understand, the Nancy standard.
Right. So this template follows the structure that you see here follows the standard. If you create the model from the template, though, you can modify it, right? Mm-hmm. So if you can do a new from template, and you can change, you can add columns to tables and things like that. What the standard really talks about is how to do these mappings, right? And so if you want to add new columns here or here, you're still within the standard.
Okay, that was my question. So the standard is not very strict. It's mostly about the connections. Yeah,
this one is not very strict, right? I mean, and there are different levels of adhering to the standard too. There's the conceptual level where you identify, as I said, orders and routings and materials and things like that. And then there would be software that said, it adheres to the standard for connectivity. And that would be a different level.
Okay, great. Thank you.
Sure. Okay, so let's take a quick look at what they call the SCED server. So this would be equivalent to what we called AE server for our ABI electronics model, but it's structured just slightly differently. And so you can see it here. And then if you look in the model here, we can go look at it in the model. Let me just grab one of these guys and then look at my task sequences. Pull that up. Right here. And the first thing that you note is that you have the number sequence is a little bit different than we had. So the standard here is we have a 10.1, a 20.1, a 30.1. Then we have a 10.2, a 20.2, and a 40. So the first thing to think about is, what do those numbers mean? And if you remember way back in the second week or the third week, or whenever we talked about task sequences, we talked about that task numbering strategy and what the implications were of that task numbering strategy. And so what this task numbering sequence does is it basically creates two different paths of execution. And so what you see is something like this. So those numbers, that number structure, remember, you have the first number and then you have the suffix, And in this case, we have the one suffix here and the two suffix here. So what that means is that these two things can happen, or these two streams of activities can happen in parallel. And this one follows this one, and this one follows this one, and so on. Okay, so the structure of the task sequence is set up so that you can have these parallel activities. However, the implementation is going to be such that we are either going to follow this sequence or this sequence. So we're going to use conditional execution so that we can either go this way or this way. And what this strategy implements is incorporation of work in process. And so on all of the models that we've done so far, we've started our model in the empty and idle state, right? So we have all the servers are idle. There are no orders or entities in the system. We click go and we start everything up. If you're using the model to do scheduling, periodic scheduling, say weekly scheduling or daily scheduling or monthly scheduling, it's not going to be that way, right? So I'm going to come in Monday morning and I'm still going to have, my facility is going to have work that's left over from the previous week, right? So it's going to be in various states of manufacture, various states of processing. And in our current models, we haven't considered that at all, right? We've just started empty and idle. And so what the template does, this task structure, is it supports that notion of having work in process. And if you look back to the tables, you can see right here, we have a work in process table. And so the work in process table lets us specify those jobs or those orders that are currently being processed in our system. So when you think about our OBI electronics, for example, we're going to have some orders that are at finish, and some orders that are at assemble, and some orders that are at packaging when we start the system. And so that work in process, we want to be able to initialize the model so that it recognizes all of that work in process. Okay, does that make sense? And so the way the task sequence is structured is this the suffix ones represent new orders to a particular server, and the WIP orders come from this line 2. And so if you look, this one, 10.1, is where we consume the raw materials. 20.1 and 10.2 are the processing times, and these are the additional setup. Or I'm sorry, not additional setup. Let's go take a look. I can't remember exactly what those two represent, but we can look it up. My thing here, so 20.1. Oh, it's my sequence dependent setup. That's right. So I consume my raw materials, and I have my sequence dependent setup, and then I process is 30.1. The thing that we don't have in the sequence for work in process is the consumption of raw materials, because since that's the first task, we're going to assume that if the work in process is already at this station, we've already executed that consume. So we don't want to redo that. We have a setup time, this again sequence dependent, and then we have the process time. And then task 40, which happens on both, is the produce step. So where we produce whatever, oops, sorry about that, where we produce the inventory or the materials corresponding to this server. So you can see that we're either going to, through the conditions that I'm about to show, we're either going to go this way and do 10.1, 20.1, 30.1, and 40. We're going to go this way and do 10.2 and 20.2. Okay, everyone with me on the concept? We haven't really talked too much about the implementation, but just the concept of what we're trying to do.
I have a quick question.
Okay.
So I was wondering, is it safe to assume that if we have a work in process, we don't need warm-up time for our model?
Well, so for these types of scheduling models, we don't want to warm up. There's really nothing to warm up. Right. We have a fixed set of things that we're going to schedule. If we're running an analysis model or a design model where we want to incorporate randomness and think about experimentation and such, that's when we want to talk about a warm up where we're trying to get the steady state. But in these types of models, there is no steady state, right? We're running the model for a set of things that we're trying to schedule.
Okay, thank you.
Anything else on this concept or anything of the other concepts we've talked about? Okay, so let's see how we do this. So we have these conditions here. And so this 10.1 condition and the 20.2 condition, I pulled out these conditions from the task sequence. So if I go back, if I go back to my model, just open this, you can see here's 10.1. This conditional execution, the condition here is what I pulled out. So if I just mouse hover, and you can see that manufacturing order status, list.order status new or something. So I just copied that exact expression and put it in the slide so that we can look and see what this means. So task 10.1 condition, the way to think about this is we have a blue part and we have a red part that's separated by an or condition. So the blue part says, is this a new order? In other words, it's an order that's not WIP. An order is either new or it's WIP. So the 10.1 condition says it's either new or it's WIP, but it's not WIP, it's not starting at this station. So if you think about a WIP order, for example, in our Obby electronics, we might start out the model with it at the assemble station, right? And so when we start the model with it at the assemble station, we need to take the fact that it's already been there for a while into consideration. But at the subsequent stations, like finish and package, it just looks like a new order. And that's what this condition tests for. So you're going to hit 10.1 is true if it's either a new order or if it's a WIP order, but that the WIP order is new to this server. Okay? Make sense?
Quick question.
Yep.
So when we initialize the model, are we the ones that define if an order is work in progress or if it's a new one, or this takes place automatically at some place in the model itself?
Yeah, we're going to see it's in the order table.
Okay.
So the order table, you have to tell it. So you have to have, you have to specify an order as WIP, and you also have to say where it is. We're going to see that here in just a second.
Thank you, Dr. Smith. Madison, you're not muted, by the way.
Eliana, do you have a question?
It was similar to the question that you just answered, but yeah, I just want to know where we define if it's a new.
Yeah, I'm going to show all that here in just a second.
Not, but yeah.
Yeah, I'm going to show some of the details here, but two things I want you to keep in mind. First of all, the easiest way to do this is just kind of listen along. I mean, ask all the questions you want, but not particularly detailed, because like when you look at these expressions, they're really hard to read. And so what I want you to do is understand how I have the blue and the red separated and what the blue does and what the red does. And then you can go back in and look at exactly what that means, because it is critically important to make it work like you want, but it's really kind of complicated to look at because these are fairly complicated expressions. And then I'm going to get to some of the details of the WIP records here in just a second. Okay, so again, what we have is the 10.1 condition says, is it new or is it new to this server? And the 10.2 condition says, is it WIP and is it starting at the current station? Right, so we have an or condition here and we have an and condition here. And so what that implements is the fact that if an order is new, it will always follow this sequence. And if an order is WIP and it's starting at the current station, then it will always follow this sequence. Okay. And that implementation that you guys were asking about, if I go back to the discrete part production and then go look at, I have two things that we didn't incorporate into our models, is if you look at manufacturing orders, I have this order status. The order status is what tells me whether it's WIP or whether it's new. And I have the work in process table, which is mapped to the orders table by the order key. And it says, where is the order in its processing sequence? So this is telling me that order 1 is currently at the weld station. I'm sorry, it's doing currently route number 20. It's at weld 1. It has completed its setup and it's completed 5 of whatever its total quantity is. Okay. And order 3 is also at route 20, but it's at weld 2. It's completed its setup and it has done 3 of its completed quantity. Okay. And if you look at this one, order 5, you can also note that we can be partially through a setup too. So order 5 is saying, okay, I'm at the cut station, which in this model is the very first station, right? And it's saying, okay, I was doing a sequence dependent setup and I'm halfway through the setup. And so it will take that time, that setup time into consideration, so that when it hits that sequence dependent setup time, it's only going to do the portion of the setup that remains. Okay, and so through these two things, the indicator order status on the manufacturing orders, and then I actually can look at it here through the extended view when you look at work in process. So there's the link for this order, which was for quantity 10, and this is saying we're halfway through. Okay, and so those two things together, the status and the work in process table, you have to input. And in a real system, this would be done by the combination of the upper level system and the lower level system. Lower level execution system would say, here's where everything is right now and the status of input, and the upper level system would give you the general order data. Okay. Questions? Any more questions about that for me? Okay. So another interesting aspect that we had not covered here. Let's see. Already done these conditions. So once again, before I go on, make sure that you do go back and have a look at these and make sure that you can reconcile how they do what I say. Again, the blue here on the top is saying, is this order new? And the red here on task 1 condition says, if it's WIP, but the current station is not the starting station, that's what the red one says here. And for task condition 2, the blue one says, is it WIP? And the red one says, and is it WIP that's starting at the current station? And so that's going to define how they're routed. Okay, so another thing that this model implements that we haven't done is work schedules. So we have talked about work schedules, and I'm pretty sure that we're going to have work schedules in case study 5. But this model the template implements work schedules actually inside the resources table. So you specify which work schedule you use in the resource table itself. And so you can see cut 1, cut 2, I guess all of these use the 5-day work week. So this 5-day work week is defined as a schedule property. So if I go back into my definitions, data, there's my work schedule, there's my 5-day work week. So this one is 8 to noon and 1 to 5. And also note that there's, for the value here, remember with the work schedule, the value indicates how many units are available, right? It's if you just have one. So if you have one operator, you can just have a 1 there. But also in the data tables, there's a capacity column, which lets you specify the capacity of the server. And so in the sorry about that, in the work schedule, that resources.capacity is what's used there. Okay. One quick note, so that if you do look at this in detail, if you want to use this model for anything that might cause a little confusion that I will just point out, you have this condition here that says if the resources is a sched worker. Okay, and so we have a sched worker here is a subclass of the worker object. So get sched worker here, it's a subclass of the worker object. And so with the worker object and the vehicle object, the capacity is handled a little bit differently. And that's what you see right here. It's saying, hey, if this is a sched worker, then the schedule attribute is a 1. Otherwise, the resource capacity. But if I go back and look at the sched worker column, right? So where are my 2 workers? Here are my 2 workers right here, team 1 and team 2. The capacity is 2. Okay, and so the way it's implemented here for workers, if I go to team 2 and scroll up here, this is done in the population. So there's where the resource capacity comes in. And that's because when you look at a server-based object that is fixed in location, like cut 1, for example, it just has a capacity. Capacity is 1, 2, 3, something like that. And that can be specified in the work schedule. If I look at a moving object like a vehicle or a worker, its capacity is always 1, but the population defines how many of them you have. So you think about this as having 2 people. you do that with a population versus with a capacity. So again, not something really you want to get too hung up on, just something that I wanted to point out, because if you do happen to use that model, that's something that's going to come up. That's something that you're going to want to know. Okay. All right, a couple more aspects of this. There are a whole bunch of custom objects. We've already mentioned that. Sched server right here. Then there's a Sched source and a Sched sync somewhere right here. And so those are roughly like we did in the Obby electronics model. These have a couple of more state assignments than we did, but basically it's the same thing. It just ties the arrivals to the table, makes some initial state assignments for the source, makes the completion time assignment for the sync, and so on. Sched server, we saw, we haven't, as I said, we haven't used workers or vehicles in any of our in any of our models so far. And then the Sched resource would be, again, equivalent to the resource that we use to do changeovers for our two stations that had sequence dependent changeovers. That's the word I'm looking for. Okay. Questions for me so far? Okay.
Is there any particular difference between a vehicle and a worker?
They are very, very similar. I can't enumerate the differences off the top of my head. There are some slight differences, but they are very, very similar.
Okay.
And they represent, a capacitated object that moves, right? So in this model, when you see, if I were to run this model, it runs kind of slow, but you're going to see, so they're the workers moving to the corresponding stations, right? And so they have a location in the model, and you can request moves. They can also carry other objects. So you can have workers carry entities, you can have vehicles carry entities, and so on. There's a slight difference. I wish I could remember what it was, but I can't off the top of my head.
Okay, I'll look it up. Thank you.
Yep. Other questions? Okay, so you're gonna, if you do look at this model, one other thing that you will see is, if you remember, let me pull up our Obby electronics model here. The way, that's not that one. That's not the right one. Electronics. Well, which one am I looking for here? No, that's the solution to 4. I don't want to show that one. I guess I don't have it open anymore. Let me open Obby electronics 3 real quick. And I want to talk about one of the primary differences here and what the implications are of the difference. If you remember, while this is coming up on my computer, we had a setup operation that we handled with a task. So we had the standard task sequence of setup, process, and finish. And then on some of the workstations, we also had a sequence dependent setup. Okay, remember that? And so in our model, if you look at the logs and if you look at the trace and things like that, you're going to see those different tasks. So here's my assemble task, for example, and it's got 3 rows, and those 3 rows are specified as 10 is setup, 20 is process, and 30 is finish. So you can think of this setup as a sequence independent setup, right? That this setup happens no matter what. If I make an order of module A red and I switch to another order of module A red, I still have this setup. Versus the sequence dependent setup that we only have if we're changing from one type to the other. And so in our finish stations, we had that. So in the finish stations, we had our normal setup, and then we interjected this second task where we're saying, okay, this is a sequence dependent setup. And so it only happens based on that changeover logic. Okay, you guys remember that? In the template, they do that slightly differently. And so let me just show that difference here and talk about that for a second. If you look, say, for example, at shape, and all of these are the same, all of the objects have the same properties because they are instances of the same base object. And if you look at these setups, they have sequence dependent setup, which is based on this sequence dependent setup matrix. Looks very similar to what we had, right? But this one is a little bit different. So let's go back and look at its definition. So if I go look at its definition, there it is. There's the changeover logic element. And note here that there are 2 rows here for setup transition. So if I open this one, you can look at this, the second one, and this is exactly what we saw before. In our model, we have, you know, the attribute that we use, and then we have the changeover matrix that is used to compute the setup time. But we also have this other component, which is a material color setup. And this is saying, I'm going to use the changeover matrix as false. And this is from a specific type to any type. So basically, this is an implementation of a sequence independent setup. And so what they do in the template is, in all stations, there you can potentially have a sequence independent setup and a sequence dependent setup. Whereas in our model, we separated those two so that we always had a sequence independent setup, and we only had the sequence dependent setup when we needed it. Okay, but in this implementation, they have this all defined in the base model instance. And the reason they do that is so that they can make the model more data generated and data driven, because all of the information is stored in the table. So the reason that all of these objects, you know, none of these objects override the standard defaults is because all of the overriding happens in the data table. So you can see here's the changeover matrix. So even though all of the objects use that same changeover logic element, only the cut station has that sequence independent setup. Okay, does that make sense? And then if I look at the routings here, only some of these routings have sequence independent setup time. So cut on finished good A, cut on finished good B, and cut on finished good C are the only ones that have the sequence independent setup time. So all of that information is stored in data. Okay. So as we were progressing in our development from the case study 3 to case study 4, what we were doing is we were systematically adding some of these features in. So that, you know, we started out with the custom object, then we further customized some of the objects, then we moved some more of the material to the data, and then the next logical step would be to go to this template where a lot of the information is stored in the table. Okay. Questions for me?
Quick question. So if I understand correctly, all the servers have the capability to do both sequence dependent setups and sequence independent setups.
Correct.
And this is for consistency and to use only one object and without having to create any derivatives of that object throughout the model, right?
Exactly right. So all of these objects, you know, only the cut stations have the sequence independent or sequence dependent, but I don't have to customize these in any way.
Mm-hmm.
Just from the data, when I go look at my resources, you can see that because they have this changeover matrix, right? So if I go back and look, at my definition of my sequence dependent setup matrix, there are my 2 rows here. You can see that the matrix isn't defined specifically. It uses that table element.
Right.
So if that table element is blank, there's no sequence dependent changeover. Same for the sequence independent changeover. It uses the routing setup time. And so if that value is 0, then it just skips it. And if you have that value as non-zero, then you have that sequence dependent or sequence independent time. And so that lets us use the same common object without customizing, without changing it. We just get all of the information from the data table.
I see. Thank you.
A couple other minor things that you would see different when you look at this one is the bill of materials have both consume and produce. And so if you remember in our model, one of the questions that we got in class was, if I'm producing my modules, either A, B, C or X, Y, Z at the end, how do I do it? Where do I do it? We talked a little bit about that. We talked about one way that you could do it is in a station. A little bit of confusion there because of the mapping between the bill of materials table. And what I showed in class was, you can also do it in the sync. So we just created those modules in the sync. What this one does is it actually has the consume and produce inside the bill of materials table. So if you look at finished good A, for example, what this is telling me is in step 10, which I believe is the cut step, you're going to consume material X and material Y. And then we get to finished goods A40, we're going to produce finished good A. We're going to produce the final product. And so if we go back again and look at the task sequence here of how that's implemented, is you have this consume, which is 1, the 0.1 here, and we have an exclusion expression right here, right? And so the consume is basically saying, I want to consume the bill of materials, exactly like what we did in our model. But we have this exclusion expression or skip requirements. And so if it's a produce, so if the material use in the bill of materials table is a produce, then we skip the consumption. Similarly, in the produce step, we have the same kind of skip requirement, but if the requirement is consumed. So what this lets us do is store both the raw material consumption and the raw material and the finished good production in the same bill of materials table, which we didn't do in our model. Okay. Two more things that I'll just mention briefly is you will see a table called material lots. And we didn't talk about this very much at all, but using material lots is a way that you can request or reserve or consume specific lots of a given material. Okay, and so you see that a lot of times in manufacturing facilities. And so the material element and the inventory element provide that capability. And so this table structure is set up to do that. You'll note that in this example model, there are no lot IDs. So basically what that's saying is we're just having an initial inventory of material X at 1,000 and material Y at 2,000. We're not actually using that lot ID properties in this model, but the table structure that is set up between materials and material lots, because again, if you look at the materials table, we don't have any initial inventory, right? There's no initial inventory in this material table, because the initial inventories are specified in the lot table. So if you were implementing a model that used material lots, using the lot ID here would let you do that. And then finally, if you look at the orders table here, it looks very similar to ours, and we have the target ship date and the target cost. Oh, we didn't do target cost. This module. This template also supports activity-based costing, and that structure is built in. But they also have a manufacturer's orders output table. And so what they're doing is in the process, they're writing values to this table. If I look at my server instances, like if I go look at a server instance here and look at state assignments, here before processing, I'm writing 4 things. And after processing, I'm writing 2 things. And you can see what I'm writing here is my manufacturing orders output, manufacturing orders output, manufacturing orders output. So I'm actually writing that output table with the information. So at the end of the run, you have all of the information in that table about all of the orders and their individual processing steps and so on. Okay.
A quick question about activity-based costing.
Okay.
So do we have the capability to add costs to an entity dynamically as it goes through the model, depending on, let's say, how much time it takes?
Well, I mean, so you have usage costs for servers. And so basically as in our case, say as the order progresses through, you can allocate costs based on what's been done.
Mm-hmm.
So when you say change the cost, I mean, the cost, the whole idea of Simio's implementation is that as you process the order through its route, you're adding cost, you're adding value, I guess. It's costing, and you're then adding value to the order, and that value depends on what you're doing to it. So the value or the cost for a cut is probably different than shape. It's different than finish, and so on. Okay, and so those are tracked again through data. So I look at my resource cost rate right here. So here's a cost rate and whatever the default currency that you're using is per hour. And so it looks like these are all 20. So we're not using different costs there, but that cost is allocated as the orders are processed. And then you have an accrued cost for an individual order. And that accrued cost is what we're seeing here based on, there's a target cost and what the accrued cost is. We haven't talked about activity-based costing, Simeo, in this class at all. It's a really nice feature, but we didn't talk about it at all.
Thank you.
Sure. Other questions for me? Okay, so there are also several elements created by the template. We saw that we've seen this before in templates, but templates in particular for this one, we have the sequence dependent setup matrix. And remember, this setup matrix actually has two setups. You have the sequence independent and the sequence dependent. Material constraints, same thing that we did, a couple of tally statistic elements, lateness and time and system, some string states, specific custom token, it gives you a default changeover matrix, the global selection rule, which I showed it. We didn't use that, but I showed it in the dispatching video, how you can apply a global selection rule. And so this template uses it. So if I go to the example and look at this, the model properties, you can see that right here, my global dispatching rules. And so if I were to go in my global dispatching rules, and if I want earliest due date to be the second priority, I can just move it up in this list, in this global list, and then that global list will apply to all of the transfer nodes. I can always override any one transfer node, but if I don't override it, then it's going to follow that global selection rule. And so I showed that again in the dispatching rule video module. And then there's work schedules. And so there's a standard, the one that we saw here is this 5-day work week, which is an 8 to 5 work day with a 1-hour lunch. Then there's the custom default entity. So it changes its initial speed, desired speed to infinity. So that gives it the equivalence of traveling in 0 time between stations, because we're not really modeling in this case the physical locations. If you were modeling the physical locations and you wanted to model travel time somehow, you just change the speed to not infinity, and it would do that. And then the initial priority is handled within the orders table. The display name, which we did, the due date expression, which we did before, and then the dynamic text, which we also did. So when you implement, when you do a new from template, you get the table structure, the objects, the elements, and the default entity. And so that's something you should definitely have a look at. Again, when you look at scheduling discrete part production, you have the models there, but also the instructions for constructing the model completely from data by using those CSV files that they have in the install directory. Okay. And so that was what I plan to talk about for the most part about the ISO 95 template. As I said, it's a really nice tool if you're as a starting point for models. When we use the ISO 95 template on actual models, you're always customizing somehow. Very rarely do you have a model that works straight out of the box for the template, but it provides a really good starting place, and it has a nice structure that you can add customization to and really kind of improve, certainly develop models like this faster, and also develop common structure models so that it's easy to transition back and forth when you're developing either new models or you're going back to old models to make modifications. Okay. All right, let me finish up. I just got a couple more things I want to just mention so I don't have to do it during the Q&A. So just again, bear with me. This won't take very long. These are just some miscellaneous topics that we didn't cover, but that I just want to mention because in developing industrial strength models, they become pretty important. So you think about, there's something called APIC style SKU identifiers. And as a quick note here, I have my little asterisk here. I don't have a reference for this Apex style. Oops, I've got a misspelling here, A6. I don't have a reference for one, but if anyone knows one, please send it to me and I will definitely use it. And if you don't know, Apex stands for Production and Inventory Control Society, something like that. Yeah, I think that's right. American Production Inventory Control Society. Yeah, actually, I don't know, but it has to do with production and inventory control. And they have a convention for doing SKU naming, which is stock keeping unit is what SKU stands for. And in this convention, a single SKU identifier uniquely identifies a single item. Okay, so it uniquely identifies a single item. So let's think about what that means. So I have a case where a company makes two widgets, widget A and widget B. Each comes in one of three colors, red, green, or blue, right? So if we use this naming convention that each SKU identifier uniquely identifies a single item, we have two widgets, three colors, we have 6 different SKUs. So we have widget A red, widget A green, widget A blue, widget A B red, widget B green, and widget B blue. Okay, does that make sense? You guys see what I'm saying? This is different than what we did, right? When we did our module A, module B, module C, we had 2 identifiers. We didn't have a single identifier anywhere. We had a module identifier, we had a color identifier, right? So we basically didn't use this convention in the models that we did, okay? But if you think about this, so consider the case where the widgets come in boxes of 5, 10, and 25, right? And so now you have the original 6 all in 3 different packaging configurations. So now I have 18 SKUs. And what happens if the packaging is in 5 different languages? And what happens if there are 3 different safety cards that are mandated by different, different organizations within a country? And so what you see when you use Apex style SKUs is that you have a lot of it. You have a lot of unique SKUs, even if you have a relatively small number of products, because of this requirement that you uniquely identify uniquely identify an item with that single SKU. So if you think about our models, right? If you think about the models that we've been working on, how would we do this, right? So think about if we want to map SKUs to materials, right? So in our models, we have module X, module Y, module Z, module A, module E, module C, right? And so we want to map those individual SKUs to materials, okay? So how would this change our basic models? How would it change it? Oops, sorry. What would change? Well, again, we wouldn't have these 2 identifiers, right? We wouldn't have the 2 identifiers. So we would look something like this. For our Hobby Electronics from case study 4, we would have module X, module Y, module Z because they were not colored. And then instead of having a module A, I would have a module A red, a module A green, a module A blue, and a module A yellow. Okay, and so now the SKU, what would be our material name, would completely define the item's bill of materials. Okay, in our model, it did not, right? So in our model, we had the name and the color. So if I were to ask you in our model, what are the components in module A? Well, you can say it's 1 component A, it's 2 component Bs, 4 component Cs, and it's one of red paint, green paint, blue paint, or yellow paint. So we don't have a unique identifier. In the Apex style, you do module A red, module A green, module A blue, module A yellow. Okay, does that make sense? Any questions for me so far?
Is there any way to concatenate 2 different names to create a unique SKU out of 2 identifiers?
Sure. You can do it outside Simio, you can do it inside Simio. So that leads to our question of, what would it lead to? So if we use the same method as we did in our model. So suppose I wanted to take our model structure, the model structure that we developed, but I wanted to implement this Apex style, right? Well, what would happen? Well, if we look at our routing table, right? So here's my routing table components for module A, right? I have a module A10, which is kit, then 20, which is assemble, and 30, which is finish, and 40, which is package, and 50, which is ship, okay? Well, if I had a module A red and a module A blue and a module A green and a module A yellow, I would have to replicate this routing table that many times. So I would have the exact same routing replicated a whole bunch of times, with the only difference being the routing key. Similarly, if you look at the component, the bill of materials, same thing. I have module A10 is where I specify component A, component B, component C, right? And then I would replicate these three, the bill of materials records for each one of the SKUs. Okay, is that you guys with me on what I'm saying here? Clear?
So essentially, we would have to repeat this for each different color available, right?
Yeah. So you would have to because remember how we use this is we map these. We have a materials table that we map to routing, and then we have an order which maps which material maps to an order. So when you have an order, you know, it maps to the routing key, and that's how we route it. And it also, the routing key maps to the bill of materials. So from that perspective, module A red is different than module A blue, even though they're the exact same all the way up to paint. It doesn't have any way to know that. So you have to replicate. And so what you would end up doing is you would have a whole lot of data that's structurally similar. Okay. So the question then becomes, is this a big deal? Is it a big deal? And that's where being able to integrate with a higher level system helps you. Because if you're doing this for a customer, a client, or a company, the company is going to have made this decision for you to a certain extent, because they're going to have the bill of materials in their standard information system. They're going to have the SKU structure defined. And so if you can import the data from the higher level system, what does it matter if I have, you know, 5,000 rows where they're all substantially similar, as long as I can automatically import them? You know, if I'm dealing with this by hand, then it's both obtrusive and error prone. But if it's automated, where I'm pulling it from, say, SAP, what does it matter? You know, so having these big tables, it's difficult if you're doing it by hand, but it's not difficult at all if you're importing from a higher level system. And speed's really not an issue, because, you know, I can have a table, my routing table or my bill of materials table can be 100,000 rows, and it really doesn't impact me as long as I effectively use the primary key, foreign key structure that that's defined here. Okay. Okay. Any last questions about this whole Apex thing and what the difference is between what we did and this?
Yeah, I have a question, Dr. Smith. Maybe I missed this part. Is this a requirement for ISA 95, or this is completely different? Apex
Yeah, this is different because ISA 95 would implement either one, right? With the ISA 95, I don't necessarily have to have the structure. I could use the ISA 95 template and still use the way that we did. In other words, we were defining a unique end product by more than one attribute. We had the module, we had the color. So we had two different attributes that defined it. And that would be perfectly fine in the ISA 95 template. It would just violate this Apex convention. But we could also have the Apex convention by just having that unique identifier.
Okay, thank you.
Okay. And let's see here. Lastly, an alternative to that is to consider something called a multi-level bill of materials approach. Oops, I don't have my closing quotes here. Put a closing quotes right here in your mind. And what that means is, if you think about our current model, right? Our current model, we have a module A, which is a component A, 2 component Bs, 4 component Cs, and 1 of the 4 paints, right? That's how we define the bill of materials for a module A, right? A module X is 1 component A, 2 component Bs, 4 component Cs. Okay, this is the approach that we've implemented in our model. In a multi-level approach, we still have the same definition for module X. It's still a component 1, 2 component 2s, and a component and 4 component Cs. But the module A uses the module X as a base. So a module A would then be a module X and a paint. right? And so instead of explicitly defining all of the components multiple times, I'm using a multi-level approach by saying, hey, I have this module X, and a module A really starts with the module X and then paints it, okay? And then if we use the Apex style for that, we would have module A red, which is module X and paint red. A module A blue would be a module X and a paint blue. You know, module A yellow would be a module X and paint yellow, and so on. Okay, so this multi-level approach is a second method that we would think about using. Okay. So if we were going to implement this multi-level approach just in our model, exactly what you're seeing here, what do you think the issues would be with doing this? So if I were to say to you for assignment 5, I want you to implement this, what would you need to do? What do you need to be able to do? Well, there are two fundamental things. First of all, you need to be able to represent it. So in the table structure, you need to make sure that the bill of materials table would support this, right? And in particular, if you look at what we have now in this multi-level approach, module X is both a raw material and a finished goods. It's a finished good if you order an unfinished one. It's a raw material if you were talking about a painted one. So module X is a raw material for module A red. It's a finished good for module X, right? So you'd have to figure out how are you going to deal with that, whether you want to introduce intermediate materials or something like that. So the whole representational is one thing. The second thing is, well, how do I deal with it? What do I do? You know, so I would then have to generate. So think about if we use this, let's say that we're using the Apex style with the multi-level bill of materials, and I have an order for module A red. And I look at the bill of materials, and the bill of materials says, okay, you need, you know, if my order is for 20 module A reds, I need 20 module X's and 20 red paints, right? So you would have to, in your model, figure out how to take that requirement of 20 module X's and then explode that into, you know, 20 component A's, 40 component B's, and 80 component C's. So you'd have to explode the bill of materials so that you could then create those components through kitting and through assembly, so that you would end up at assembly with your module X's, and then transition to paint to then consume the module X in the red paint or the blue paint or the yellow paint. Okay, so there are two basic issues you'd have to deal with here. One is how to represent it. Second one is how to do this explosion concept where if I need a module A red, I know that I need a module X, and then I also know that that would then explode into the individual components. Okay, does that make sense?
Yeah, but a quick question. So is this multi-level approach, like if we have a lot of variation within our components, then essentially we won't be able to construct a module X that we will use like commonly between different products. So for this to work and to be worth it, like I guess we would need to have a lot of components that are common across many products.
Yeah, absolutely. So where this approach is useful is when you're actually doing assemblies, right? So when you are taking, you're making, an assembled product, and that assembled product has several different subcomponents, and those subcomponents are also assembled, right? That's where this approach is useful. It's not going to be useful in all approaches. So in our case, it's useful. It would be useful in ours because I told you that module X is just an unfinished module A. Module Y is an unfinished module B, and module Z is an unfinished module C. Right. So it would be useful in ours, but there are some where it wouldn't. So if you don't have this natural hierarchical structure, then it wouldn't be a useful approach. Okay.
Mm-hmm.
And lastly, there is an example of this. Well, I already said how would this impact. I've already been through that. If you look in the examples directory, there's an example called scheduling bicycle assembly _update create MOs and POs. I hate that name, but such is life. There is an example model of this. And in this example model, you're making bicycles. and you have bicycles of different colors, and a bicycle, has a frame and some wheels and a seat, and a frame has a fork and so on. So it has this hierarchical structure. And in this hierarchical structure, it has a method for doing this bill of materials explosion. So if that's something you're interested in, have a look at this model. I will warn you, currently there's no corresponding PDF that tells you how this works. So you're going to have to open up the model and just kind of look around and see how it works. Hopefully there's going to be one soon, but there isn't one now. Okay. So this is a really interesting, this multi-level bill of materials is a really interesting process. And if you look at how this is done, right, how this is done in reality, a lot of times the planning system does that for you. So when you talk about exploding the bill of materials, the planning system will. If I have an order for module A red, it will then create a subsequent order for a module X that will then feed into this one. And so in the case where you're implementing this in your scheduling model, the scheduling model is doing this. It's a scheduling decision of when to do it. If it's done in their planning system, like SAP or whatever the planning system you're using is, then you wouldn't see this multi-level approach because all of the orders would be independent. Okay. And that is all the material I had planned for today. Anyone have any last questions, last comments? Anything you want to hear from me? Okay. Remember Thursday, I'm going to have a Q&A session. And also remember next Tuesday, we have our guest speaker. It will be on Zoom, and everyone needs to plan to be at that. Okay. Mackenzie, are we staying on after this still?
Yes, please.
Support? Okay. I'm going to stop the recording.
Okay, thank you.
Bye, everybody.
Thanks, bye.
Stop the share. Stop the recording.